we have x divided by 8 equals 5. So this one looks different than the last one, but this is still in 2.3, which is our multiplication property. And again, we're going to approach it the exact same way we did last time, and the time before that even, where we're going to do the opposite in order to isolate our variable. So right now, our variable is connected to this 8. This 8 is dividing against that variable. So the opposite of division is multiplication. So I'm going to multiply then both sides by 8 in order to do the opposite. When I do that over here on the left, I get 8 over 8, which cancels because it simplifies into 1. Then on the right, I get 5 times 8, which is 40. All right, number 14, we have a negative 27t equals 108. This negative 27, don't get confused by that negative and think, oh, it's subtracting, I need to add. No, this negative 27 is multiplying against the t, so the opposite of multiplication is division. First thing I'm going to notice after that is that I have a positive number divided by a negative number. That means I'm going to get a negative output. And I'm going to get 108 divided by 27. If you don't know, you would type it into your calculator. You are allowed calculators on test 2. You're not allowed graphing calculators, but you are allowed other calculator scientific ones. So 108 divided by a negative 27 would give you a negative 4. The big thing is when we start playing with negatives, we got to keep track of them and be really careful, because there's nothing worse than typing in 4 when you meant negative 4 and then you miss the whole problem because of that. All right, number 15. We have 6/5 x equals 24. Now in 2.3 we learned that we can do the opposite, which is what we've been doing, or we can do the inverse method. And honestly, the only time I use the inverse method when it comes to solving equations is on problems like this, where the coefficient or the answer, either one of these, is a fraction. If that's the case, then I'm going to choose to use the inverse method. And the inverse method says that you take the inverse of your coefficient, the number attached to your variable, and you take that and multiply both sides by your inverse. Now, the multiplicative inverse in this case is where we take the coefficient and we flip it. So if the number that I'm starting with is 6/5, the inverse of that will be 5/6. We just flip it. But if I multiply the left by 5/6, then I have to multiply the right by 5/6. What that does on this side is we'd have 30 over 30. If you have the same thing on top and the same thing on bottom, they cancel out. So my x will be completely isolated. Now, on the right-hand side, I'm going to write this one additional step so that you can really see what's happening here. I'm taking 24 times 5/6. But remember, if we do a fraction times a fraction, or a whole number times a fraction, we need to make our whole number into a fraction by sticking it over 1. Now, we have a couple of options here. We can do the multiplication. Multiply straight across the top, straight across the bottom, and then make sure you simplify. I call that simplifying on the back end. I don't love simplifying on the back end because typically it means you're going to be using your calculator more often. And I try to use my calculator the least amount that I can so that I'm acquiring the math skills. So what I like to do is I like to simplify on the front end. So that's before I do the multiplication. This simplifying on the front end only works with multiplication. It doesn't work with addition, subtraction, or division, so you have to be really careful about that. But since we have a fraction times a fraction, I can simplify on the front end by looking at 24 and saying, okay, is 24 going to be 6 times something? Because if so, then I'll have a 6 on top and a 6 on bottom, and they'll cancel each other out. Well, it just so happens that 24 is 6 times 4. So what that means is on top, I have 6 times 4 times 5. On bottom, I have 1 times 6. If you have the same thing on top and the same thing on bottom, you're allowed to cancel them out. So instead of taking 24 times 5, now what I have to do is take 4 times 5, which is 20. And on bottom, I'm left with 1 times 1, which is 1, so I just find that x is 20. No calculator was needed for this problem because I chose to do the simplifying on the front end. So that's just my choice. All right, number 16, negative 15 equals a negative x. Again, just like earlier, if you don't love that there's not a number in front of your variable, you are more than welcome to write it as negative 1x like this. And then maybe that'll kind of show you a little bit or highlight what it is you're going to do next. Because this problem is really no different than some of the ones we've already dealt with in this review, and that I have negative 1 times x, or I have a negative times x. So in order to isolate my variable, I'm going to divide, because that's negative 1 times. I'll divide by negative 1, divide by negative 1. Negative divided by a negative will produce a positive. 15 divided by 1 is 15. All right, number 17, we have negative 6x equals a negative 42. It's almost exactly what we did up here. Except instead of dividing by negative 1 in order to get x by itself, I would divide by a negative 6. And again, I get a negative divided by a negative. That's going to produce a positive. 42 divided by 6 will give me 7. Scrolling on down. Number 18, we have negative 4k minus 4 equals a negative 16. These are multiple step problems. Negative 4k minus 4 equals negative 16. So we have two different numbers that are attached to our k, or on the same side as our k. We have the negative 4 that's being multiplied, and we have the negative 4 that's being subtracted. Or the 4 that's being subtracted, however you want to think about that. So the way that I've described this in the past is that this negative 4 is kind of hugging that k, and this negative 4 over here is kind of like a handhold. It's a lot easier to break a handhold than it is a hug, so we're going to get rid of the handhold first. This is our addition property. We do it first. So in order to move the negative 4 over, we would do the opposite of negative, which is positive. But if we add 4 on the left, we got to add 4 on the right. That'll leave me with a negative 4k equals negative 16 plus 4 is a negative 12. Now this negative 4 is multiplying against the k, so we do the opposite, which is division. So we divide both sides by negative 4. Again, negative divided by a negative means I'm going to get a positive outcome. 12 divided by 4 is 3. Number 19 says use the distributive property to help you solve the equation. So that's what I'm going to start with, because I can't do anything else first. There's nothing else for me to do in this problem except start with distributing. So I'm going to distribute the 9 to the w to give me 9w. 9 times negative 5 will give me a negative 45, and that equals 36. Now this problem is pretty much identical to the problem up here, in that I got to get my variable by itself, so I'm going to break the handhold first, use the addition property. Since it says minus 45, I'm going to add 45 to both sides. That'll leave me with 9w on the left, and that will leave me with 81 on the right. That 9 is multiplying, so I divide, and I find that w equals 9. All right, number 20. 20, we have more stuff, more terms, but we can't do anything with the terms as they sit right now. We got to start by using the distributive property to distribute that negative 6 inside of my parentheses. So it's going to start off with that 5x, because he's just along for the ride for a minute. Then I take negative 6 times x, giving me a negative 6x. I take negative 6 times 3, giving me a negative 18, equals 12. The big thing here is remember that you're not just distributing the number, you distribute the sign that's in front of the number as well. So that is the number one mistake I will always see on this problem, is the negative 6 will get distributed to the x, but it doesn't always get distributed to the 3, so just be careful on that. Now, on the left-hand side, I do have some like terms here. I have a 5x and a negative 6x. I can combine those into a negative x minus 18 equals positive 12. To get x by itself, I'm going to break that handhold using my addition property and adding 18 over to the other side. So I have a negative x equals 12 plus 18 is 30. And then this problem is exactly like what we did up here in number 16, where we have negative x equals a number. So in this case, I have negative x equals 30. So what I'm going to do is divide by the negative 1, divide by the negative 1, and I find that x is negative 30. And I'm careful because, see, I had a positive divided by a negative, so I end up with a negative 30. So, all right, 21. I'm going to solve the equation. And right here, I have lots of like terms because I have a 7x and a 6x and a 3x. So I can combine those. 7x plus 6x is 13x. Minus 3x minus 5 equals 25. I still have like terms here though. And you could have done all this on one step if you're really good with that. But I was just showing you every step possible. 13x minus 3x will give me a 10x. And then at this point, we're back to the handholds and the hugs, in that we're going to break the handhold by doing the addition property and adding the 5 over to the other side. That'll leave me with 10x on the left equals 25 plus 5 is 30. To get that 10 away from my x, I gotta get dividing by 10. But if I divide by 10 on the left, I have to divide by 10 on the right, so that I find x is 3. Any of these problems that we are actually solving for x, you could test your solutions by plugging them back into the original and making sure you get a true statement. That's always something that's a good habit to do on a test, in that after you've worked through all the problems, if you still have time on the exam, go back and test your solutions, because you might find that you accidentally dropped a negative somewhere along the way. And that's a great way to double check and just make sure. All right, let's do our fraction problems. Those are everybody's favorite. So 22, we have 1/2 x plus 7 equals 1/6. Now, there are multiple ways we can do this problem. I don't know about you, I don't like playing with fractions that much. So I like to use the LCD, or least common denominator method, so that I can get rid of my fractions straight out of the gate. So what we have to do in order to do the LCD method is we look at the denominators we're given, 2 and 6. And we say, what is the least common denominator between these denominators? And if we don't know, one way you can figure it out is you take your largest denominator, in this case it's a 6, and we write out some multiples. 6 times 1 is 6, 6 times 2 is 12, blah, blah, blah. You don't really have to go out very far. And the question you're asking yourself is, okay, does 2 go into 6? And right there off the gate, we're good to go. 2 does go into 6, so 6 is actually our LCD, our least common denominator. Now, what we do with that is we multiply every single one of our terms, the 1/2 x, the 7, and the 1/6. We multiply every single term by 6. So I take 6 times 1/2 x. And I take 6 times 7, and I take 6 times 1/6. Every term, fraction or not, gets multiplied by the LCD. What that will do is it'll take 6 halves, so 6 divided by 2 is 3. We get 3x. 6 times 7 is 42, and 6 times 1/6 would give us 6 over 6, which is 1. So instead of worrying about 1/2 x plus 7 equals 1/6, we're going to worry about 3x plus 42 equals 1. They're all whole numbers. Nice, neat. I like that. So to get my x by itself, I would subtract 42 from both sides. That'll give me 3x equals 1 take away 42 will give me a minus 41. Divide by 3, divide by 3. And I get x equals a negative 41 thirds. Minus 41 thirds. Now, so we got a fraction as an answer, but we didn't have to play with fractions the whole time. So this is the way that I choose to do it. Could you have subtracted the 7, gotten a common denominator, and then divided by the 1/2? Absolutely you can. And as long as you do all your math right, you'll still end up with the exact same answer. But I don't know, like 99 out of 100 students always want to get rid of the fractions. So this LCD way lets us do that. And we're going to use the LCD way down here to get rid of our fractions here as well. Because we have 7/8 minus 6/7 equals 1/28. And again, I'm going to find my LCD the same way that I did up here. I'm going to take the largest denominator, which is 28, and I'm going to write out some multiples. So 28 times 1 is 28. 28 times 2 is 56, and that's really about as far as I need to go. Most of the times, anywhere from 2 to 4 terms is about as far out as you're going to have to go. So then the question becomes, does 7 go into 28? Yeah. Does 7 go into 56? Yeah, so it doesn't really help us there. What about 8? Does 8 go into 28? No. Does 8 go into 56? Yes. So 56 is the first number that all 3 of my denominators can go into. So that is my least common denominator. So I'm going to multiply every single term by 56. So I'm going to take 56 times 7/8 minus 56 times 6/7 equals 56 times 1/28. And then I'm going to choose to do that simplifying on the front end bit, because here's the deal. I don't want to take 56 times 7 or even 56 times 6. Those are going to be some big O numbers, and I don't want to deal with them. So what I'm going to do is I'm going to write 56 and hopefully be able to cancel out my denominators and make some smaller numbers. So 56 is 8 times, hopefully you're saying 7, because that would be correct. But if that means I have an 8 on top and an 8 on bottom, those 8s cancel. So instead of taking 56 times 7, I'm now taking 7 times 7. That's 49. Then I'm going to do the same thing over here. 56, as we just said, was 8 times 7, but in this time, my denominator is 7 down here, 7 up here. So I'll be taking 8 times 6, which is 48, instead of 56 times 6 and divided by 7. Same thing on this right-hand side, only this time I'm saying 56 is 28 times something. Luckily, we did that up here. 28 times 1 is 28. 28 times 2 is 56. So that's 28 times 2. Cancel out those 28s, meaning you have 2. And then look at this. 49s minus 48s leaves me with a single s. This problem always looks super gross. You always get something super nice. Like you'll get 2, 3, 5, something like that. If you're getting some weird big O fraction thing, odds are you've done something wrong over here. Just saying. That doesn't mean there's anything wrong with those types of answers, but I've taught this problem for 13 years. It's always something nice like that. Okay? Multiply by the LCD to get rid of your fractions, and then you have nice numbers to play with. All right, let's look at number 24. 24 says solve the equation. So if I look on the left-hand side, nothing for me to do. They're not like terms. If I look at the right-hand side, I do have some like terms, and then I have a negative 7y plus 5y. I can combine those. So I'd have 5 minus 2y equals 8, and then I have negative 7y plus 5y, giving me a negative 2y. Now I have variables on both sides of my equation, so I'm going to group them up. I'm going to move all of my variables to the left. That means I have to take this minus 2y and move it to the left, so I have to add 2y. But look what happens when I do this. I'm going to have 5, and then I have a minus 2y plus 2y. Those cancel out. They go to 0. So then I have 8 equal, and then I have a minus 2y plus 2y. Those cancel out. So I have 5 equals 8. Is that true? Does 5 equal 8? I promise you I'm not trying to trick you. It really doesn't. 5 does not equal 8. This is false. So if we get a false statement, then what that means is that there is no solution. Our variables went away, and we get something that's false. Nothing's going to work in that equation. Nothing. This is known as our contradiction. So let's look at the next one. Solve the following equation. So I'm looking. There's no fractions. That's always what I want to go for first. I do have a set of parentheses that I want to get rid of, so I'm going to distribute that negative 2 to the positive 3t, giving me a negative 6t. Take a negative 2 times negative 5. Negative times negative is positive. 2 times 5 is 10. then don't forget, I still have this plus 5 over here on the left-hand side, and all of that equals 3t plus 10 on the right. Now, I do have some like terms over here on the left, in that I have, make that a rounded t, 10 plus 5, which is 15. And then at this point, I make a choice. Notice I have t's on both sides, I have constants on both sides, so I've got to get all of my constants on one side, I got to get all my variables on the other. I generally will pick to keep my variables positive. So I have 6 negatives over here, and I have 3 positives over here. If I add my 6t to move it over, then I get to keep positive t's. The reason why I do this is the least amount of negatives I have to deal with, the better off I am in the long run. So on the left, I'm left with 15. On the right, I had 3t plus 6t is 9t. And then I still have the plus 10. To get t by itself, I break my hand holding first. I buy my addition property. So I subtract 10 from both sides. 15 take away 10 is 5. The 9 is multiplying against the t. The opposite of multiplication is division. So I get 5/9 equals t. So that would be, the solution is t equals 5/9. This is a conditional equation. This equation only works, it's conditional on the fact that t is 5/9. All right, let's look at 26. 26 is fraction equal fraction plus fraction. It's a lot of fractions. So I would treat number 26 the exact same way we treated number 23 up here. Multiply everything by the LCD and get rid of those fractions. Always. So we have 3, 6, and 9 as our denominators. So I'm going to look at 9 because that's the biggest. 9 times 1 is 9, 9 times 2 is 18, 27, blah, blah, blah. And then I say, okay, does 3 go into 9? Yes, 3 goes into 18, 3 goes into 27, so that doesn't help me. 3 goes into all of those. So what about 6? Does 6 go into 9? No, but 6 goes into 18. So 18 is our least common denominator. And I'm going to multiply everything by 18. So I have 18 times a minus 4 all over 3. I'll have 18 times 5a over 6. And I will have 18 times a minus 34 all over 9. And 100% I'm going to simplify on the front end, because if I don't, then I have to distribute, and then I have these fractions. Like, the whole point is to get rid of fractions. So I'm going to do that. So 18, since there's a 3 in the denominator, I want to think, okay, 18 is 3 times 6. That means there's a 3 on top and a 3 on bottom, so those can cancel. That would leave me with a 6 times the a minus 4 on top. Equals, then I do the same thing over here. 18 is 3 times 6, as we just said, but this time the 6's get to cancel, meaning I'm left with 3 times 5a. Now, could you go ahead and do this multiplication bit? Absolutely, you could, but I'm trying to write out all the steps so that when you go back to reference it, you don't think, holy crap, where'd you get 15a? This way you'll know where I get 15a. My last fraction has a denominator of 9, so I'm going to think about 18 as 9 times something. 9 times 2 will be 18. That way my 9's will cancel, leaving me with a 2 times a minus 34. Now, I do have these sets of parentheses, so I do need to do distribution to get rid of them. And I'm going to do the distribution both on the same row. Because since they're on opposite sides of the equation and they're separate from each other, we can do that. We have 6 times a giving me 6a. We have 6 times negative 4 giving me a negative 24. Here, I can also go ahead and choose to do this multiplication here because it's a completely separate term. So I have 3 times 5a giving me 15a. And then I'm going to distribute the 2 to my a, so I get a 2a. Distribute the 2 to my 34, giving me a negative 68, if I can math. 68. This is the problem with doing math in a pen. All right, there's nothing I can do right now on the left-hand side, but on the right-hand side, I do have 15a plus 2a. That'll give me 17a, and then minus the 68. And again, it doesn't matter which way you take your a's and which way you take your constants, but I'm going to choose to take my a's and make them positive. Since I have 17 a's on the right and only 6 a's on the left, I'm going to move all of my stuff over to the right to keep it positive. So that means I would subtract the 6a over. So I have a minus 24 equals 17a minus 6a will give me an 11a minus 68. Break that handhold first by adding 68 to both sides. Negative 24 plus 68 will result in a positive 44 equals 11a. Divide by 11, and I find out that a equals 4. Again, this is another one of those problems I've taught for 13 years. It always gives you a nice number. If you're getting something weird and crazy or a big O fraction, odds are you've done something wrong. Almost done. All right, 27, our slight word problem, not really, but very slight word problem. Use the appropriate formula to determine the area of a rectangle and the perimeter of a rectangle. So first we need to know area of a rectangle. Area of a rectangle is the length times the width. The perimeter of a rectangle is 2 times the length plus 2 times the width. And then they give us the length and the width. The length is 10, the width is 4. So then it becomes plug and chug as long as you know your formulas. It's asking for area first, so we're going to do length times width. Length, as I noted up here, is 10. Whoops, that should be an A. Length is 10, width was 4, so my area equals 40. Now, this number 1 is a drop-down box where it gives you yards cubed, yards, and yards squared. We took a yard times a yard. If you take a yard times a yard, you're gonna get yard squared. Area is always units squared, always. Perimeter, though, is not. Area is always units squared. Perimeter, though, when we plug in, we get 2 times our length, which was 10, plus 2 times our width, which was 4. 2 times 10 is 20. 2 times 4 is 8. So I find that the perimeter is 28. The perimeter is the amount that you would have to fence in if you were fencing in this rectangle. The area is the amount you'd have to mow or color. So my perimeter is 28, but in this case, I just took yards plus yards. If I'm taking yards plus yards, I'm going to always end up with yards. So area is always units squared. Perimeter is always just whatever the units are. All right, last problem on the review. Solve for M. Now, this one, guys, you got to be so careful. This S, that's capital. That is a capital S, and we have to treat it like a capital, and we have to write it as a capital when we type it into Pearson, or we will be counted wrong. Be careful. Whatever variables they give you, those are the variables you have to give them back. All right, so I'm trying to get M by itself. This is like the only variable that's actually going to stay a variable, basically. Everything else moves over. So if I'm thinking about this, that this is the one I'm trying to isolate. Right now, I have it plus D divided by 2. So in order for me to get this by itself, the first thing I need to move is this 2. Since everything on top of being divided by 2, the opposite of division is multiplication. So I'm going to multiply the right-hand side by 2, but if I multiply the right-hand side by 2, then I multiply the left-hand side by 2. That'll give me a 2s, and it's a capital S, equals the 2 here and the 2 here would cancel, leaving me with M plus D. I'm still trying to get M by itself, so I would subtract the D from both sides, and I have 2 capital S minus lowercase d equals M. So in my answer box, because it already says M equals, I would just put 2 capital S minus D. Be very careful, because sometimes they'll give you like a capital A or something like that. If it gives you a capital, you have to give them a capital back, or you will end up missing the problem.